Greetings students. In this video, we are going to see how to identify the model MMC Infinity FIFO, that is multi-server infinite capacity model. How to identify the model and hence how to solve it will be seeing by taking one problem. Okay. Consider the problem. In a supermarket has two girls running up the sales. Okay. In a supermarket, it is given that has a two girls running up sales at the counters. So sales counter, how many girls are there? Two girls are running up the sales counter. Means there are two counters in the supermarket. So how many counters are there? Two counters. So the number of servers here are two. Okay. Two servers. So that is multi-server model. Is there anything given about the capacity? If the service time for each customer is exponential with mean 4 times, they are talking about the service rate. If people arrive in Poisson fashion at the rate of 10 per hour, arrival rate they are talking about. Nothing has been specified about the capacity of the system. Okay, so we can take the problem as infinite capacity. So this is multi-server infinite capacity model. What is multi-server here? C. C is given as two girls. That is, there are two servers here. So in this problem, specifically C is 2. Okay. So we have identified the model. Next task is we have to identify what is arrival and what is service rate. Okay. What is arrival rate? If people arrive in a Poisson fashion at the rate of, directly they have given the rate of 10 per hour. So arrival rate is 10 per hour. Okay, if the service time for each customer is exponential with mean 4 minutes. So exponential with mean 4 minutes means rate is nothing but reciprocal of the mean. So we'll take mu as 1 by 4 minutes. So here in the problem, arrival rate is given in terms of hour, service is given in terms of minute. So we have to convert both to the same unit. Either we have to convert both to hour or to minutes. Okay, we'll convert arrival rate to minute now. So 10 hour is nothing but 10 divided by 60 minutes. That is 1 by 6 minutes. So lambda is 1 by 6 and mu is 1 by 4. Once we have identified what is lambda mu, next task is to find rho. Rho is nothing but lambda by mu, that is 1 by 6 divided by 1 by 4. That is 2 by 3. Simplifying, we'll get rho as 2 by 3, which we'll be using in all the formula. Okay, next is what exactly is being asked. Notation for the subdivisions. Okay. What is the probability of having to wait for the service? They are asking you the probability that arriving customer should wait for the service. Probability that the arriving customer should wait for the service. When the customer will wait? Only when all the servers are busy. So if the number of customers in the system is greater than or equal to 2. Okay, because there are two servers already. If until two customers arrive, they'll get the service immediately. Only when the customer more than 2, they have to wait. Okay, if the number of customers in the system is 2 means they need not wait. If it is more than or equal to 2, they have to wait. So probability of the arriving customer has to wait for the services. Probability that the number of customers in the system is greater than or equal to 2. Okay, so next subdivision, what is the expected percentage of idle time for each girl? Idle time. Here girl denotes the server. Okay, idle time for the server. Always idle time. Rho denotes the busy time. Idle time means it's 1 minus rho. Okay, percentage of idle time means it's 1 minus rho into 100 generally. But here there are two servers. If it is single server, we'll calculate it as 1 minus rho. If there are two servers, we have to find the rate. So idle time for each girl is nothing but 1 minus rho divided by C. Rho simply means busy time. Rho by C means there are two servers, so per server. So 1 minus rho by C denotes the idle time for each girl. Percentage of idle time means we have to multiply this by 100. Okay, this is the notation for second subdivision. Third subdivision is if a customer has to wait, what is the expected length of waiting time? Okay, so if the customer is waiting, what is the expected length of waiting time? So length of waiting time, we cannot have it as length of the queue. There is separate formula for this that we will discuss in the formula section. Okay, what exactly is this? We will discuss in the formula session. Okay, coming to the formula to be memorized in this model. So the model is MMC infinity FIFO, multiple server infinite capacity model. As usual, Little's formula is LS is equal to lambda WS, LQ is lambda WQ, WQ is WS minus 1 by mu, LS is LQ plus lambda by mu. Once we know any one of these four, we can identify, we can calculate the remaining three using Little's formula. So in this model, what is the thing we should memorize is LQ. Okay, LQ is given as lambda by mu C minus lambda into P of n greater than or equal to C. What is P of n greater than or equal to C? Denotes probability that the number of customers in the system greater than or equal to the number of servers. Okay, then only Q forms, no? That's why we are multiplying that with P of n greater than or equal to C. What is the formula to calculate P of n greater than or equal to C? It is rho per C into P naught by C factorial into 1 minus rho by C. What is P naught? P naught is summation n is equal to 0 to C minus 1. Rho per n by n factorial plus rho per C by C factorial into 1 minus rho by C, the whole inverse. So these are all the formula we should memorize in this infinite capacity, multi-server infinite capacity model. Okay. Apart from this, if they ask you what is the average number of customers in non-empty queue, it is given as lambda by mu C minus lambda. And what is the expected waiting time? Means it is given by the formula 1 by mu C minus lambda. That is our third subdivision is if a customer has to wait, what is the expected length of waiting time? So expected waiting time is nothing but 1 by mu C minus lambda. This we'll use for third subdivision. Okay. Okay. Next one we should remember is fraction of time a server is busy. Already I have discussed this. Always, whenever the ratio rho, that is lambda by mu, we calculate, that denotes the fraction of time, the time that the server is busy, that is denoted as rho. Here there are multi-server means fraction of time a server is busy. That is denoted as rho by C. Here in this case, it is rho by 2. Okay. So coming back to the question, we'll calculate the subdivisions one by one. First subdivision is what is the probability of having to wait for the service? That is, we have to find P of n greater than or equal to 2. What is the formula for P of n greater than or equal to C? It is rho per C. C is 2 here. P naught divided by 2 factorial into 1 minus rho by C. That is 2 here. C is 2 here. Okay. In the place of C, we'll replace 2. For this, we have to calculate P naught first. What is P naught? Summation. N is equal to 0 to C minus 1. C is 2, that is 0 to 1 here. Rho per N divided by N factorial plus rho per C divided by C factorial into 1 minus rho by C, the whole inverse. We have to calculate this P naught. Okay, so what is rho? Rho we have calculated as 2 by 3. We substitute the value of rho here. Okay, rho is 2 by 3. So summation n is equal to 0 to 1. So first we'll take n is equal to 0. Rho per 0 is 1. By 0 factorial is 1. So 1 plus rho is 2 by 3, the whole square. divided by 2 factorial, 1 minus 2 by 3 into 2 plus n is equal to 1. That is rho per n. 2 by 3 power 1 divided by 1 factorial plus 2 by 3 the whole square divided by 2 into 1 minus rho by c. Okay. Here there is no n factor, no? There is no n factor involved here. So we'll simply calculate this. N is equal to 0 means it is rho per 0 by 0 factorial, that is 1. N is equal to 1 means it's rho per 1 by 1 factorial plus rho square by 2 factorial into 1 minus rho by the whole inverse. So we'll calculate this. Simplifying this, we'll get P naught as 2 inverse, that is 1 by. So P naught is 1 by 2. Okay. Then substituting this P in P of n greater than or equal to 2, we'll get rho square, that is 2 by 3 the whole square into 1 by 2 whole divided by 2 factorial, that is 2 into 1 minus 2 by 3 into 2. 2 will get cancelled. Simplifying this, we'll get P of n greater than or equal to 2 as 0.1667. Okay. So moving to second subdivision, that is what is the expected percentage of idle time for each girl? That is 1 minus rho by c into 100. Percentage it's asked, so into 100. So 1 minus rho is 2 by 3, c is 2 into 100. That is 1 minus 1 by 3, 2 by 3 into 100. That is 200 by 3, that is approximately 67%. Okay. Next, third subdivision. If a customer has to wait, what is the expected length of waiting time? So in this model, expected length of waiting time, multi-server infinite capacity model, expected length of waiting time is given by the formula 1 by mu c minus lambda. 1 divided by, what is mu here? 1 by 4. C is number of servers. 2 here minus lambda is 1 by 6. That is 1 by 2 minus 1 by 6. Taking 6 as LCM, you get 2 by 6. Reciprocal is 3. Everything is in terms of minutes, no? So expected length of waiting time is 3 minutes. Okay, what is the expected time the customer has to wait? That is the expected length of waiting time. Okay, so in this model, that is multi-server infinite capacity model, these are all the formula to memorize, and this is how we have to solve the given problem. I hope you are clear with this model. Thank you.